have any questions on the simplified radical form worksheet? Were there any who were stuck on any of those?
Yes.
Okay, which one?
12.
Number 12? Number 12 or square root of 12?
Number 12.
Number 12 is 27. What times what is 27? 9 times 3 is 27. Is either of those a perfect square? 9 is a perfect square, so it ends up being 3 square roots of 3. It's 9 times 3, so it ends up being 3 square roots of 3. I did it as square root of 9 times 3, so I end up getting 3 square roots of 3. Anyone else have any other questions on this one? I have a key. We can check yours when I'm done rambling. Okay, so let's look at the bell ringer. Write the equation in slope-intercept form. What form is it currently in? Why are you always in trouble with me and I've yet to fix it? What form is it currently in? It's currently in point slope form. How do we put it in standard? Yeah, you just guessed. Yet again, eventually one day I'll have my life together and we're going to take a quiz on that because I'm tired of you not knowing. Okay, so what do I do?
Subtract 3. Well, you can distribute first.
I'm going to distribute first. Okay, so I have y plus 3 equals what?
1/2 x plus 2.
Plus 2. Okay, and then what?
You subtract 3.
Okay, if I subtract 3 from both sides and I press autofocus lock, okay, at the same time, I get y equals what?
1/2 x minus 1.
Okay, that's great, but I could have just graphed the point -3, -4, and I knew the slope was 1/2, and I would have gotten the same line, and I didn't have to do all this work. Okay, some people were asking me questions about number 2. It says, express the area of the triangle below as a monomial. Someone remind me of the formula for the area of a triangle. 1/2 what? Base times height. Okay, so what is my base?
4b.
4b, it looks like a cube d squared.
Yeah, something like that.
Okay, and then what's the height?
3b.
Okay, so if I start multiplying, I'm just going to leave the 1/2 alone for a second. 4 times 3 is 12. B to the third times b squared. What should I end up getting? B to the what?
B to the 5th.
Do you get b to the 5th or do you get b to the 6th? Why? Thank you. You add the exponents. We only multiply the exponents when we're raising power. So automatically b and c are out. And what they're testing is, do you know your rules of exponents? When we multiply with the same base, we add the exponents. Okay, so I have b to the 5th and d to the what? 7th. Okay, and that's great, which is what answer A is. However, we've still got to do that 1/2. So it makes it 6. 1/2 times 12 is 6. So 6 b to the 5th, d to the 7th, which is d. Again, Kiana's showing me that she understands her rules of exponents right then. And you see how they almost tricked some of us, or they could have tricked us into selecting the wrong one just by making us question our rules of exponents. So that one was a good one. Okay. Are there anyone with any questions on rules of exponents? Anyone with any questions about radicals? We talked about how to break it down in different ways. Specifically, the mathy way was to figure out the largest perfect square that divides into it. And I noticed a lot on that worksheet, it tended to be 4. Most of the time it was 4. Okay. So that learning target, the top one, I can add and subtract radicals. It's been there for what? Like days now? Days. Forever, I feel like. So we're finally going to do that today. It starts off, you can only combine,
Like terms.
we're not going to call it like terms, we're going to call it like radicals. But yes. So that kind of requires us to know what a like radical is. So let's see, like radicals have the same blank and the same blank. It's going to be vocab terms from radicals. What are they going to have the same? They're going to have the same index. They are going to have the same index. So if I have a cube root and a square root, they can't go together. And they're going to have the same Please take a wild guess. Radican. It's the thing underneath the house, underneath the radical. So the same radican. So if you've forgotten your vocab terms, cube root of x to the fifth, the x to the fifth part is called the radicand. The whole giant thing was called a radical. The house-looking symbol was called the radical symbol. And then this little tiny number was the index. I have some people who aren't writing their index very tiny. Please be careful and let there be a difference between your regular numbers and your little tiny index numbers. Otherwise, Miss Compton gets confused, and when she gets confused, she tends to grade you in an ugly way. Okay, what do you have to do in math before you get to start combining things? What are you supposed to do first?
Write it out.
I guess I didn't ask that well. For instance, if you're looking at this example down at the bottom, they have the same index, but they have different numbers under their radicand. But is there anything we could do before we start solving? Look at the problem. We could simplify. We can simplify that radical. So what I'm going to write in the box is simplify everything first. Before we try to decide whether or not they combine, we need to simplify. Simplify everything. Simplify every single thing first, if you can, before we try to decide, oh, those two can or cannot go together. Okay, and the last little sentence is to combine like radicals. It's just like when you have an x. So if I had 2x plus 5x, what would my final answer be? You just add the 2 and 5 and get 7, and the x's stay the same. It's going to be the exact same thing. We're going to add the coefficients the way we added the 2 and the 5. And we're going to keep the radical, we're going to keep the same radical. The way when we add 2x plus 5x, it suddenly doesn't become x squared. Yeah. I wasn't even looking at that. Thank you, dear. Notice that 2x and 5x, just 7x, not 7x squared. We leave the x alone. We just combine the two coefficients. We're going to do the same thing with radicals. Are there any questions so far? We have 2 examples only because I swear if you've already been practicing on the other worksheets, this is just combining what you've been doing all into one. So how can I break down 45? What times what is 45? 9 times 5. Why do I want to do 9 times 5? Not 15 times 3, for instance.
9 is a perfect square.
9 is a perfect square, and you can use your perfect square card if you need it still. Okay, so what does square root of 45 end up reducing to? I'm going to put it in parentheses. You gave them a divorce. You do the square root of 9. Okay, 3 square roots of 5. If you actually want to write the step where you give them a divorce, so you have square root of 9, square root of 5, which is how you got 3 square roots of 5, that's fine. Does anyone have any questions about this step? Okay, I'm going to multiply. What's 2 times 3?
6.
Okay, so I'm going to multiply. I'm going to have 6 square roots of 5, and then minus 2 square roots of 5.
3 square roots of 5?
6 minus 2?
4.
Yeah. Okay, so Natalia's already on to the answer, and I'll go ahead and write it. But the important part is Natalia understands how we simplified it to this step. So we realize they really do go together. They have the same index. They have the same radicand. When Hannah first saw this problem, she thought they're not going together. They had the same index, but they had different numbers under the radicand. But once we simplified that left side, it turned out they had the same number under the radicand. Are there any questions about this? Okay, then I don't need Kiana or Natalia to help me, but I need some help on this next one. Not Josh either. Roberts. Not Josh Roberts either. Okay, I need help simplifying 12. What multiplies to give me 12? 6 times 2 does, but so does 4 times 3. Which one do I choose?
4 times 3.
Because why?
Because they were
But which one's a perfect square? No, not both of them.
4.
4. 4 is a perfect square. Okay, so 3 square roots of 3. Can I break down square root of 3 into anything? I don't think so. And then what times what gives me 20?
5 times 4.
Okay, 4 times 5 or 5 times 4, either one. I get that 20 times 2, and I get there are other options, but we want to go with 4 times 5 because 4 is a perfect square. Okay, so I get negative 3, and then what do I have once I simplify that square root of 12? What does it become? No. 2 square roots of 3, because the square root of 4 is 2, and the square root of 3 stays the same. I'm not going to mess with that 3 square roots of 3. What do I get on the last one with the square root of 20? What does it become? No. Yes, John David. No more John David. Okay, so on my next line, what should I write?
6.
Negative 6. Square root of 3. No more from you, ma'am, either. And then what else?
Plus 3 of 3.
And then what else?
Plus 6 of 5.
Okay, Ty, you're out too.
Yes.
Anyone who I haven't declared out, tell me what to do on this next line. Who gets to combine? We've simplified it as far as we can. Who gets to combine?
I know. I know who.
I don't need you to tell me who. I don't need you to tell me who either. Kiana, let me get the answer, and then I'll answer your question.
It'll probably be answered once.
Oh, yeah, she's out. She just has a different question. She's on a different thought. Okay, is there no one else who knows the answer?
I know it.
Okay, you're going to feel bad once Josh tells you. Josh, tell us.
Oh, wait, hold up. Yeah, 3 square roots of,
So he just did 6. 3 plus 3 plus 5 is 11. Are we supposed to be adding under those radicals? Okay, which ones are alike? Oh, these two are alike, so we can combine them. What do we get when we combine them? Negative 3. Then what? Okay, square root of 3. And then I'm just going to bring down that plus 6 square root of 5. Why can I not combine those two? It has two different... Oh, they don't have indexes different. They're both 2's, but they have different numbers under the radicand after we reduced. This is my final answer. Negative 3 square roots of 3 plus 6 square roots of 5. This is my final answer. Are there any questions about this? It's really taking everything you've been doing and just letting you combine it and actually do a little more math with it. Okay, I handed out the multiplying. We're actually not going to divide, but dividing is very similar. Multiplying and dividing. And we're just going to multiply. Okay. Do we say it again? On the study guide, there were like 6 with adding and subtracting, so you could have extra practice with that since I didn't have an official adding and subtracting worksheet. Okay. But I can find you another one if you would like it. Okay. We can multiply radicals if they have the same index. Okay. I don't want to regret this. There is a difference between adding and subtracting and multiplying. Notice with multiplying, they don't even have to have the same radicand. They just have to have the same index. Okay, so there are 3 steps. The first step is to multiply numbers that are outside the radical symbol. So I'm actually going to do that second example. Numbers outside the radical symbol would be the 2 and the 4. So 2 times 4, that's 8. Are there any questions about that step? Our next step is that we're going to multiply the numbers under the radical symbol. So in this one, I'm going to multiply 12 times 15, and my brain has left today. I don't know what that is.
180.
And then step 3 is what you were expecting, because it tends to be in every single problem. Simplify. Okay, so let's talk about what I'm doing. I multiplied the numbers on the outside, so I did 2 times 4 and got 8. I multiplied the numbers on the inside, so I did 12 times 15, and I got 180, but notice the radical symbol didn't leave me. It's square root of 180. Square root of 180. And then, of course, my last step says simplify, so now I've got to figure out, can I break down 180 into some perfect squares, and I bet you can. 90 times 2, but 90 is not a perfect square. I don't know if 16 goes into this, or I'm sure 9 does 20 times. 9 times 2 is 8. 36. Somebody goes into it.
36 times 5.
Okay, so 180 is really 36 times 5. 36 times 5.
There. What are you writing in colors that mean when you put?
Oh no, it didn't mean anything. I was just being colorful. I'm just going to swap, but I was trying to be colorful. It doesn't mean anything.
Like when you had step 1.
Oh, I did do that. I didn't even mean to. Wasn't even intentional. I mean, technically this was step 1, this is step 2, and then what we're doing here is step 3. And step 3 might take a couple times because obviously we're not done simplifying. What does this end up becoming? Like if I leave the 8, what does square root of 80 become? Square root of 180 become? Is it 8? Okay, 6. Yes, ma'am. Thank you. 6 square root of 5 is correct. Thank you. And then what is my final answer going to be? Yes. 48 square root of 5, because 6 times 8 is 48. Again, so my step 1 was I multiplied the numbers on the outside. I did 2 times 4. I got 8. I multiplied the numbers on the inside. I did 12 times 15. I got 180. Natalia gets most of her points for doing step 1 and 2 correctly. She shows she's got some stuff. Now, of course, Natalia's going to get all her points if she shows me she can simplify square root of 180, because that's what we've been working on. She figured out it was 36 and 5. The square root of 36 is 6. Square root of 5 stayed under the house. 8 times 6 is 48. Okay, let's go back to the easier example. Square root of 3 times square root of 3, what should I get?
Would you not use those 3 vectors?
Yeah, it's still going to give me square root of something.
I'm against that.
Yeah, what do you think? Do you think she's right with square root of 9?
No.
Okay, what numbers are on the outside? The index is 2, yes.
0.
Oh my goodness, in life there's an understood 1 in front of things, killing the smalls. So really, if we're multiplying the outside numbers, we're doing 1 times 1, which is 1. Do you even have to write what I wrote in green? No. Then you have to multiply the numbers under the house. So you get square root of 9. She was right with that. So we've done step 1 and step 2. Technically, there really wasn't a step 1. And then square root of 9 is a perfect square, so what is my final answer? 3. Yeah, you were right. I just need confidence. Okay, and then we've got another one. So what do I need to do in this kind of a math problem? It's technically still multiplying, but what do we call it? We're going to distribute that square root of 3 to both of them. So we're going to have 3 square roots of 3 and plus the square root of what?
6. 9?
Wait, are we?
Wait, I don't even get it.
Okay, so we did 3 times square root of 3. I distributed that one.
18.
And then I'd have square root of 6 times square root of 3. And when we have, I'll write it like that if that makes you happier. It is where we multiply underneath. So they're both under the house, so we can put them together. 6 times 3 is 18. That is true. Do I normally write that step? No, I don't. I normally would have thought 3 times 6, square root of 18. And then am I done? Or is there anyone I can simplify?
Oh, you can't you do 3 and 3 is just 3.
Is there any of the radicals that I can simplify? I can't simplify any of them?
No.
I can simplify 18. What is 18? 6 times 3, but is either of those perfect squares? Thank you, dear.
9 times 2.
9 times 2. So let's do 3 square roots of 3 plus 9 times 2. What do you end up getting for the second one?
3 to square root 2.
Yes. Okay, can I combine them and say the answer is 6 square roots of 5?
No.
Do they have the same index?
Yes.
Do they have the same number under the radicand?
No.
No, so we can't combine them and we're done here. This is our final answer.
Let's go.
And the last one, which is probably the...
Hardest one.
No,
Oh, this
I don't think so. But what do we do to solve this? I'm looking for a word. It's an acronym. Does no one know FOIL?
foil.
Y'all don't know how to FOIL? Okay. We're gonna fancy distribute. That's what we're gonna call it. We're just gonna distribute, and I am gonna actually be careful with my 2 colors this time. Okay. I'm gonna distribute the square root of 3 to both the other people. And if I did, I would get 3 square roots of 3, and then minus 4 what? So if I did this times this, I got 3 square roots of 3. I did this times this and got minus 4 square roots of 3 times 3 is 9, yes. Okay, so I distributed because square root of 3 times square root of 3 would give me square root of 9. I know that simplifies. I don't care at the moment. I'm going to come back to it. There's more parts. I need to distribute the 3 to both people. 3 times 3 is 9. I'm running out of room, so plus 9. And then 3 times negative 4 is negative 12 square roots of 3. So I wrote in 2 colors. To show you that 3 times square roots of 3 was 3 square roots of 3. This times that was negative 4 square roots of 9. But this distributing didn't just involve the square root of 3. It also has to involve the 3. 3 times 3 is 9. 3 times negative 4 is negative 12 square roots of 3. Okay, I need to combine all these if I can. I'm going to put, let's see, I know for sure this one and this one can go together. What would I get if they go together? I heard it. I just need a confident answer. I have 3 square roots of 3 and then minus 12 square roots of 3. What should I end up getting?
We'll put it outside, correct?
Yes. So we already did all our multiplying. Now I'm just wanting to simplify and combine like terms and such. So since those two had the same index and the same radicand, I was going to go ahead and combine them. 3 minus 12, John David's right, it is negative 9. So negative 9 square roots of 3. Can't nobody go with that plus 9, so I'm going to write him again just because I can. And then can I simplify that minus 4 square roots of 9? What is the square root of 9?
3.
So, oh Lord Jesus, help us all. For the bajillionth time, I keep getting on to you, and I do love you. But you can't just give up on a problem because it took more than 2 seconds to figure it out. That's not how you're going to get to AP Cal. I've showed you how I distributed. You can't possibly have a question about that green or purple line right there. There's no way. And then you understand that from here I need to simplify. I can put these two together because they had the same thing under the house. They both had square root 3. So 3 and negative 3 go together, they make negative 9. Woohoo. 9 I just brought down again because he didn't have anybody to go with him, or so I thought. Negative 4 and then square root of 9. I know the square root of 9. That's 3. And then there's still more math that I can do. I'm going to write the negative 9 squared root of 3 again. I'm going to write the 9 again. But I know negative 4 times 3. That's negative 12. And then there's still one more step I can do. Because I can put that 9 and negative 12 together and get negative 3. So my final answer is going to be negative 9 square roots of 3. And then all minus 3. There are not any like this on your test. However, should you be able to follow what I did? Absolutely. Absolutely. Okay, what I need you to do is I need you to be working on either one of the worksheets from last week, or I'm going to have to walk around and give you options on your main.